So in this video, I'm going to focus on the functions and domain and range. So this is going to be questions 20 through 25. Question 20 is giving us a pattern, and based off this pattern, we're being asked to create a table followed by a mapping diagram. And the two things that we're going to focus in are the stages versus the number of tiles. So in the first thing we're doing in creating a table, you always want to make sure that you label. We're talking about the stages and the tiles. Based off this, the independent is going to be the stages. If we know what stage we're on, then we can determine how many tiles we have. So for my X values, I'm going to go ahead and represent it as stage. And then the Y values are going to be our number of tiles. So for the stages, we see we have 4 stages. So there's 1, 2, 3, and 4. And then from the tiles, we want to go through and see how many tiles are in each one. So here we're going to go and count. We have 1, 2, 3, 4, 5, 6, 7 tiles in the first stage. In the second stage, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, and 12. This is going to give us 12. And then in the third stage, same thing. 2, 3, 4, 5, 6, 7. This will be another 7. So that gives us 14, 15, 16, and 17. And in the last stage, some of you might see a pattern start to emerge. Same thing, we're going to count 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22. We have 22 tiles in that last or fourth stage. And then from here, we need to do our mapping diagram. So the mapping diagram is when you have those large ovals, and in the left column is going to be those X values. So we have 1, 2, 3, and 4. And then the last oval is going to be the Y values, which in this case is our number of tiles. So it's going to give us 7, 12, 17, and then 22. And then the last thing you want to do is make sure you draw in those arrows. 1 gets paired with 7, 2 gets paired with 12, 3 goes with 17, 4 goes with 22. In this problem, we're talking about finding the domain of this function. Domain is going to be the X values. So when you're looking at a graph, you want to remember that the X goes from the left across to the right. And usually you're going to see that indication with the variable along the edge of the coordinate plane. So we're going from left to right. We're going to go from the negatives to the positives. And so when we do that, it's best if you use your pencil or your finger to go from one side to the other. So here I'm going to use a vertical line because I can use that to go left to right. And starting from the left, I first encounter the graph at the -2. This -2 is where I first hit the graph. This is the X value. So I'm going to go ahead and write -2. My X value is going to be included. So I'm going to underline the inequality. My X values are bigger than that -2. But if I keep moving, the graph is going to complete at that positive 4. So because the graph completes at positive 4, I'm going to put a 4 at the end. Because the circle is filled in, I'm going to include it. And so we read this as x is greater than or equal to negative 2, but less than or equal to positive 4. In this problem, we're being told that the domain of this has the values 2, 4, 6, and 8. The question is, what is that range? So in other words, we're being told we have the x values. We want to know the y values. We have to find the y values. And remember, your y values can go in place of f of x. F of x is the same as y. So if I go ahead and I take this equation, instead of f of x, I can go ahead and write in y. Y is going to equal 1.5 times the x value plus 4. And so to solve this, we're going to substitute. First, we're going to substitute the 2 in place of x. So I'm going to have y equals 1.5 times my x value of 2 plus 4. One 1.5 times 2 comes out to 3, and 3 plus 4 gives us a y value of 7. So right now, as part of my answer, I have 7. That's what we got when we had 2. So now I'm going to go ahead and go on to the next value of 4. So same thing. I'm going to do y equals, this is going to be 1.5 times the x value now of 4 plus 4. So we go ahead and see 1.5 times 4 is 6, and 6 plus 4 comes out to 10. So we get a y value of 10 given the x value of 4. So I'm going to go ahead and write 10 over as my next answer. That 4 has been taken care of. Our next value is going to be 6. So we're going to come back. Y equals 1.5 times the y value now of 6, or excuse me, the x value of 6 plus 4. Then we go ahead and we simplify. 1.5 times 6 comes out to 9. And then we still got to go back and add the 4. 9 plus 4 comes out to 13. So we have a y value of 13 given the x value or domain value of 6. Then we have our last one, 8. So this time we're going to put 8 in place of y. So I have, or excuse me, in place of x. So we have 1.5 times, instead of the x value, is going to be the 8. And then we add 4. Go ahead and simplify. By the way, you will have access to a calculator. So if you're looking at the decimal and you're not quite sure how to work with it, put it in your calculator. Okay, so 1.5 times 8 is 12. Add the 4, and we get y has a value of 16 when we have that x value of 8. And that completes our set. So we're left with the range of 7, 10, 13, and 16. I know that 16 is a little hard to see. So in this problem, we're being asked to identify the range represented by this graph. The range is the y values. So we're looking specifically for all the y values that we would find on this graph. So a lot of times when students see a graph like this, they want to go straight to the points. But keep in mind, you have y values all along these curves. So regardless of how your graph looks, when you're talking about finding the y values, you're going to go from the bottom to the top, because that's how the y-axis goes, from the bottom to the top. And then once again, it's the y values, so we're looking at y. It is a continuous graph, so we're going to have the inequalities before and after. And then on the left side, we're going to be looking for the lowest value, and the right side is going to be the highest value. So this will be our lowest, or over here is our highest. So once again, I'm going to use a vertical, a line to kind of help me see. So I have a line here, moving from the bottom, because that's where the lowest y values are. I hit the graph at the base of that curve. And then we want to go ahead and see, okay, well, what value is that? So off the y-axis where the line's crossing, the y-axis, what value would this be? And if you're not quite sure, you can always count the squares. And you'll see, starting from 0, -1, -2, -3, -4, -5, -6 is the lowest y value. So the -6 is going to go on the left. This is a curve, a shaded curve, so I'm going to go ahead and underline the inequality symbol to include it. And then I'm going to go ahead and keep going all the way up. I'm not going to stop here because there's still graph above those points. So I'm going to keep going all the way until I get to the end, which is a value of 2. 2 is the highest value here, so I'm going to put a 2. I don't see any open circles, so I'm going to go ahead and include. So this is telling us that y is takes on all the values greater than or equal to -6, but less than or equal to +2. So in this problem, we're asked to complete a statement so that a negative correlation is represented. A negative correlation means we have, as something increases, something is going to decrease, and there is a relationship among the two. So in this first question, it's talking about a runner's speed, and then the left is up for us to answer. So when you think about this, as somebody runs fast, in turn, what's going to happen? That would go down. And here we could say a runner's speed and time to complete a race. As this person runs faster, the time it takes to complete a race is going to decrease. In our next problem, we have the apples in a bag, and we need to complete it. Once again, we need one to increase and the other to decrease. So here we could say the more apples that we put in a bag, that's going to affect the space remaining in the bag. So the more apples, the less space we have for other items. Coming to the third one, the temperature outside, and then we are talking about the amount of people. What about these people? Is what we want to fill out. So, and this one can be a little confusing for some, because when you think of the temperature outside, you have to think, okay, if the temperature is at 70 and it's going up 80, 90, it's getting hotter, and we want, what will we have fewer people do? So we could say the temperature outside and the amount of people wearing coats. If it's going to get really hot outside, you're going to have few people wearing coats. Then we go to our last one, the people in a household, and then we need to complete that, making a negative correlation. So once again, if I have something going up, something needs to go down, and there needs to be a relationship between the two. So we have the more people in a home, then we could say the less amount of leftovers we're going to have. Now, these are just some examples. Remember, when you're doing a correlation, you need two things that relate to each other. And if it's negative, you need one to increase and one to decrease. In this last question for the video, we're told the function f of x equals 3x squared minus 5. What is f of negative 11? So when you come back, recall f of x, you have what is inside is the x value, and then you have the entire thing is the y value. So here we're looking at what is inside. So this is an x value of 11, negative 11. And that is going to go in place of the x of the equation. So I'm going to go ahead and rewrite f. Sorry about that. F of negative 11 is going to equal 3. This is going to be times the x value of negative 11, so that goes in the parentheses, squared minus 5. And following the order of operations, we're going to go ahead and take care of the exponent first. Once again, when you have your test, you'll be able to type this whole thing into the calculator if you choose. You got to make sure you put that negative inside parentheses, because this means you have 3 times negative 11 squared. So this is going to be negative 11 times itself. This is negative 11 times negative 11, which gives us a positive 121, and we still got to subtract 5. So I'm going to go ahead and condense the 3 times 121. 3 times 121 comes out to 363, and we still got to subtract the 5, and we're left with f of negative 11 is equal to 358.